All right, good afternoon, everyone. You're welcome to today's event, which is hosted by Bincom Dev Center. And this is the Cloud Hosting Meetup. And today, the theme for the event is Cloud Compute and Containerization. And we have two speakers who will be speaking to us on that knowledge area. For our first speaker, his name is Momodu Ismaila. He is an adaptive, skilled, and innovative DevOps engineer with extensive experience working cross-team, designing and implementing DevOps methodologies that meet enterprise business needs, migration of applications, and adoption of CNCF standard cloud native approach. His experience working in diverse agile environments, Scrum and Kanban, working across technical teams to deliver KPIs and OKRs. Ladies and gentlemen, please make welcome Mr. Momodu Ismaila. Mr. Momodu, thank you for being with us. You have the floor
now. Thank you very much. That was quite high profile. I want to say thank you to Bincom for this wonderful opportunity. And to everybody that is present, welcome. The profile was quite too serious. I'm somewhat a playful person. So this section is more of, I'm just going to be sharing some kind of jokes and what have you. And of course, I have a slide prepared. So if you don't mind, I will just start sharing my screen right away. Okay. Can you see my screen?
Yes, I can.
Oh, okay. Okay. So preparation for this talk, I was kind of thinking of what how I'm going to put everything together. First off, I thought about doing a demo, but then there are a lot of demos on YouTube out there. And I also thought about doing just introductions to some tools out there, but then you can find those ones in their documentations. So I opted for sharing my experience, more like talking about experiences that most people, especially newcomers, will not be familiar with. So yeah, so let's start. We're going to start with what I call introduction to the cloud DevOps and SRE comrades. And I'm sure everybody's familiar with Comrade, the trending, I think they call it Pepe the Frog, that we see most times on the internet. Yeah, so I'm going to be introducing everybody to what I call the cloud DevOps comrades. And the first on our list is the software DevOps comrade. This is a DevOps engineer that has a background in software engineering. They spent most of they spent previous years working as DevOps, as software engineers, either front end or back end. So moving to DevOps is more of they're bringing their knowledge of front end and back end engineering to DevOps. And then there is the second comrade, which moved to DevOps from a system admin. Before cloud or before cloud computing or what have you, we used to have on-site, on-prem servers where we have people that manage networks, routers, just system administration and network engineering. So the second comrade is more of that person that moved from that kind of field into DevOps. And then there is the third one, of which I believe most people on this session belong to. This one started tech journey to become cloud DevOps engineer. Like they started their tech journey just because they want to enter cloud So their first experience with tech is cloud and DevOps entirely. So I believe most of us are in that category. And of course, there is the fourth one, which I currently work with someone in the fourth category. The person basically knows everything. Every topic you raise, the person is there. The person can work. The person is not moving. It can come out as a software engineer. It can come out as a system admin. It can come out as a cloud DevOps engineer, product owner, anything. Just mention it and it's there. And I'm sure if we're going to have anyone yet, there's probably 1 or 2 persons that will be here. But then introduction. Yeah, I am the second comrade. I moved from system admin down to cloud, and of course DevOps, and of course these are some highlights. More like the unserious profile. I have 1 or 2 certifications. I can't count, maybe 5. Then I spent most of my years of experience in the cloud, container architecture. Yeah, I used to have cows, or I used to walk around the cows. Not not like a herdsman, but I used to like walking with cows. And then, of course, the rest are just there for. I want to be a farmer, but I'm scared of being kidnapped because I have a farm somewhere in those states. But then I don't like going to the farm. I don't want to go to the farm one day and then they're asking for how many millions where I don't get. So my contacts, email and Twitter, and of course, I'm very lazy with WhatsApp messages. I hardly reply messages. I think I reply emails better. So if you have any feedback or if you want to tell me how I can get better with my presentation, you can always email me. But if it's WhatsApp, it will be hard. All right. And yeah, so next is basically just setting the context, right? Defining the terms and of course, going from there. The first one is cloud compute, of which we all know what it is. Cloud compute is basically on-demand virtual servers or machines in the cloud, and basically in the internet. And the cloud there means internet. I remember introducing somebody to cloud computing, and I gave the person the same definition. The person was like, "Cloud, like, do we have servers stored up in the cloud?" And I had to like break it down that cloud is internet, and of course containerization. An OS level virtualization method. But basically, you can read it. But I decided to highlight the without. Sorry, come. This way. Oh. I decided to highlight without launching an entire virtual machine for each app. So basically, a lot of people don't. Should I say, differentiate between containerization and microservices. So a microservice is not necessarily a containerized application in the sense that microservice is distributed applications with extensive service deployed separately as smaller, loosely coupled service. This can be done with or without containerization. So I can decide to deploy microservices to different virtual machines. If I have 10 virtual machines and I have 10 services running in each of those VMs, like GCE, AWS, EC2, or Azure virtual machine, if I have each service running in those virtual machines, it's a microservice. But then containerization is putting this application in an OS level virtualization method, of which I believe we're familiar with it. I think the first container tool that came out in public was Docker, and Docker has been useful till last year when Cloud Compute Foundation is basically Cloud Compute Foundation is trying to like override Docker, to just put it into a tool that would just use in our own sandbox environment. They don't want to use the Kubernetes anymore. What are we? But Docker is like one of the most popular Docker container tool. So if you want to like kickstart containerizations, you definitely have to experience Docker and Docker files. Yep. And then the progressional trends. a lot of people, like people that belong to the third commit category, always like ask, okay, what's the next tool to learn? Because there are a lot of tools. DevOps is quite like it's very, very big. Like you can work in a certain company. I've worked in a company before where I used some certain tools, and I went to another company and I was blank. The tools that they were using they were quite different. I had to start learning all over again. So a lot of people tend to ask that question: what do I learn? How do I stand out? And what have you? So I'm going to like walk you guys through a trend of cloud compute and containerization. And the first one I want to start with is the infrastructure as a service, which basically started cloud computing, right? We have GCE, the Azure, and different services that you have there. And those days, let me use those days because it's like 5 to 6 years ago. But let me just say those days. Some of the things you needed to, some of the tools you needed to know were Ansible, Puppet, Bash, Python, Jenkins, Terraform, and what else. Basically, just to provision and maintain your virtual machines in the cloud. And then there was now an evolution. I think, yeah, Google Cloud started the evolution on the platform as a service. They introduced App Engine, of which AWS joined, but then App Engine kind of changed everything. The cloud providers are telling you to bring your application, they are going to host it for you. You don't need to worry yourself about managing. Now, if you started your journey with App Engine or BizTalks or App Service or all those managed services, you might not have hands-on experience with Linux administration. You might not know the pains of having to create users, having to create volumes, and just like basic system administration tasks, right? Because all you have to do to host your application with BizTalk and App Engine is know your Docker, know your cloud SDKs. All you have to do is command like App Engine start, App Engine, Elastic BizTalk, something, and of course your managed CI/CD platforms. So in those days, you have to write bash scripts. Sometimes go through Jenkins just because you want to deploy a certain application. But these days, from the era of platform as a service, we saw the rise of CI/CD platforms like GitLab, CircleCI. So I would say if you start your cloud journey with platform as a service, it's somewhat the smoothest and probably the laziest because you hardly learn most of the background stuff. And of course, there came containerization as a service, of which we have EKS, GKE, well, basically Kubernetes and other container orchestration tools. And the skills you needed, or the tools you needed were basically Docker. You needed to understand how Kubernetes work or how container orchestration works. And then service mesh, Terraform, CI/CD, Open Policy Agent, and many more. And I think last year during the KubeCon, there was I was in like a small group section when they were talking about the phasing out of tools like Puppet, Ansible, because most of the things we need right now for Kubernetes has been built into managed service. For example, you needed in those days, if you are setting up your own Kubernetes environment, you needed your Ansible to set it up, to configure, or you needed your Puppet to configure your servers. But right now, we have corps, we have different Kubernetes tools that you can use to set up your clusters without SSHing into the server itself. So the talk was more about, okay, how do they phase out this Ansible, Puppet, Bash, and Bash is everlasting. Like the basic tool that we're using for infrastructure as code, they were talking about how to phase it out. But then the trend that's involved now is blockchain. And we did a POC in my place of work, I think last month, on how blockchain is going to phase out containers. Right? Because the essence of containers is for us to have a well-designed, scalable infrastructure, whereby if we have increase in traffic, we have an infrastructure that can just scale to take the traffic and, of course, multiply the containers and what have you. But then applying it in blockchain is quite like an overkill, because in blockchain, you don't need to control your own scalability. All you have to do is control your nodes, contribute your node to the whole network and what have you. So with the emergence of blockchain nodes and blockchain as a service, like, you basically don't have to start thinking of phasing out Ansible or Puppet, because it becomes useful again, right? There's no, like, if you're employed for a blockchain company right now that manage their own nodes, or they want to put you as an infrastructure engineer in a blockchain company, you have to know how to enter into a Linux machine or a Windows machine, whatever is hosted in blockchain, and do your system administration work. So at the end of the day, it's all a cycle. There's nothing like what tool do I need to know, what tool is currently facing out. It's basically all about what you want to do or what your organization is currently working on. So it might be the best with Packer, Jenkins, and Puppet, and like, you're the best. You know deep down that nothing comes up with Puppet and Ansible that you won't be able to tackle. And then somebody brings, and then you join or you move to another company, and then you're seeing Elm, where you have to write M files, and then you're seeing Open Policy Agent, where you have to write Rego files, and you're seeing Terraform, where you have to write Terraform configuration files. So it's all like a cycle for you. So it's like I said, it's more of what is your organization currently using and how good are you with that. And at the end of the day, DevOps is all about continuous improvement, right? So there's no, I know this tool. It's all about, are you willing to learn this tool? If this tool is going to drive your organization to the promised land. If you're trying to move to infrastructure as code, and then you are not using Terraform, are you willing to learn Terraform? How willing are you? How willing are you trying to improve your system? How willing are you going? Can you go? Let me say, can you go to improve your system, right? That's what DevOps is all about. So the trends is going to be repeating itself. Tomorrow, we might just say, okay, want to phase out Terraform, have a new tool, and all of a sudden, everything is working for or against you. And then, yeah, so I decided to talk deeper into containerization, because a lot of times when we talk about containers, right, we tend to think like container is like an application on itself, whereby container is just containerizing an application is just part of the problem or part of the solution. Let me not say problem, because but containerization is a problem on its own. But then let me say it's part of the solution on my own side. So to my left, this is left. It might be your own right. To my left-hand side is an application that is containerized, and each of these boxes is a service. Let's say this is Facebook, where this is a comment, this is a live streaming microservice, and this is the ads, and of course, Facebook groups. Now, and then there's database. So let's say these are the containers. Now, what most of us won't see, or if you don't have any experience with containers, are the components that makes this application work. I'm sure most of us are familiar with AWS environment. So I'm going to use AWS as an example, like the tools that we're going to use. Now, in between this user and these small containers are different services that you have to know, which is still cloud compute, right? For example, in AWS, API gateway is also called API gateway. Like the resource is called API gateway, but AWS decided to call their own API gateway as well. So a user wants to say get users' comments on Facebook. The user hits the API. Then there is another from year to year, there can be over 10 different services or 10 different resources between this application, this API gateway, and this user comment. One of those is content CDN, forgotten the D. Content delivery network, yeah, content delivery network. And of course, we have the messaging queue system. Then we have the caching system, and we have the load balancers. Then we have the ingress, Istio, Messio, and what have you. So from here to this place, it's a whole lot. So if you're talking about containerization, it shouldn't just focus on, okay, how do we containerize this application? You have to think about how we're going to containerize this application and make it highly available. Because containerization is not a solution on its own, it's part of the solution. Like currently, we're working on an application in my place of work, because I said I want to talk about my own experience in my place of work, where we have users distributed in the US, the UK, and Canada. And then our database is mostly in US East, which is AWS US East 1. And then the way the application was previously designed didn't take the people in UK into consideration. So right now we're facing latency issues, whereby people in the UK are having a hard time trying to, when they hit our API, we don't get it on time, so it takes time. And that's back to user management. So right now, what we're doing is we're deploying a new version of our application, not really a new version, we're deploying new microservices. And in these microservices, we're writing different cache systems. And of course, putting it in the CDNs and spreading it across the edge locations around the world, so that we're mostly in the UK and Europe entirely. And to do this, like to be able to implement this feature, you have to know exactly what system architecture is. You need to understand the different sections of designs. You cannot just say, okay, because AWS said you should use so for so. You're going to use. You need to understand the principle behind that and why you should use that. For example, if you work in an AWS environment and I ask you to give me the principles of load balancing, you're probably going to come up with the principles that the load balancers that AWS load balancers work with. You have network load balancers, application load balancers, and classic load balancers. These load balancers have their own different principles. But these principles that these AWS load balancers work with is quite different from the general principles that load balancers, like global load balancers, work with. That's why you talk about load balancers like round robin, weighted round robin, and different principles and algorithms that these load balancers work with. And for you to be able to pick the load balancer that you are working with, for you to be able to pick the load balancers that you are working with, you will need to know a bit of that. And of course, managing systems as well. Like I told you guys, it's more of a cycle. You cannot say you have so tool and then you are good to go. You can go to another company and then it's a different tool. But there are some basic tools that you just need to understand in DevOps as far as cloud computing and containerization is concerned. And some of these tools, I'm going to talk about them later. And then I don't think what was that? Okay, time is almost up. So to my right hand side is the other UI, the other application. I was supposed to talk about this more, but then hold on. Yeah, so this one is basically the same thing with the first one, but the only difference that we have here is this one is talking about the front end, the back end, and of course the APIs that is attached to a container. So this architecture and this architecture might look the same, but they are different. Whereby you have to like think it through, like this particular user interface. Let's say you are the user here, you are the browser, and this particular one is just like you are hitting the API. Let's say you are using the Flutterwave API, whereby you are using the payment gateway. This the left hand side diagram is what you will use. And right now you're using Zoom. This right-hand side is what you will use. So basically what happens on the ground is a lot more than containerization. It's system architecture, it's system design, it's DevOps. And yeah, so back to the comrades that most of us identify with. Most questions that I get from people, by the way, I mentor a lot of people. I have a program that I run once in a year to drag people, to drag people into cloud computing. And most of the questions I get from them is how do they grow or how do they thrive? And I'm going to be personal with you guys right now. DevOps is broad, right? And it's, should I say, it's tempting. It's also tempting, especially if you're starting. You can just get a job and then you have to, most of the times, right? DevOps interviews do not really require, like for small companies, DevOps interviews do not require technical or coding interviews. And most of them do not require coding interviews. So you can easily find yourself working in an environment that you don't have the experience to work in. But then you just have to fast forward your career because, well, we're Nigerians now, we're also need money. So like the advice I'll give you guys is take time to learn. Like you need to learn and then of course go and make your money. You can still make your money and learn, but ensure that your journey is such that you pick learning over money anytime that it is presented to you. And of course, the general question is, what do you need to try in DevOps field? And I have just 3 pictures for you guys. And these pictures have different sizes. So this is a comrade. The first one is a comrade with system admin background. The second one is a comrade with the software background. And the third one is the comrade that knows everything that has to do with working in an environment. So first one, you basically need system admin skills. Like you need to understand how the Linux system, because most of the systems, most of the servers we are running in the world today are Linux. You need to understand how Linux works. Take your time to learn Linux, bash, scripting, file system, and what have you. And then the second one is software engineering. Like you need to understand the basics of software engineering, the architecture, how software works, how it is designed, how it is deployed, and what have you. And I also advise that you know a programming language, Python or anyone. But Python is like the most popular. And of course, the third one is know everything, right? Not like know everything, just have an idea of how most of the things in an environment. So for example, DevOps is more than just the tools. DevOps is made up of people, tools, and culture. So you need to understand the difference between Kanban, Agile, like how DevOps came to being, sprint planning, product management, and what have you. And of course, I'll suggest a book for you guys. I think the name of the book is The Phoenix Project. Phoenix, PH. Oh, let me just type it there.
Okay, Mr. Mahmoud, you have like 5 minutes left.
Yeah, I'm actually done. So that is all I have for you people today, and I hope that questions will get me to talk more about my experience. I just wanted to give you guys an overview of what cloud compute and containerization is all about.
For questions, there is one here already. It's from Michael Alex. So he's asking, do you have an idea how the blockchain technology influences the cryptocurrency, or is it?
I'm not a blockchain. I'm not a blockchain developer per se, but you're asking if blockchain, like technology itself influences crypto, but basically crypto runs on blockchain, right?
You're right. You're right.
Right.
So,
You're right.
yeah, Michael,
Yeah,
if you can rephrase your question.
Okay. This is what I meant. What I meant was this. I wanted something here about what the same blockchain was used in creating.
Sorry, you're breaking. Is it just me?
That's what I was saying. Can you hear now? Can you hear me now?
Yeah, better.
Michael, you're breaking up. I don't think we can hear you.
Okay, so let me just help
Okay,
Mr.
let me
Mamadou
type the
out.
question.
Since I know a little of the crypto, let me just help Mamadou out. Okay, Michael, crypto is basically, blockchain is basically the platform to which crypto operates without a central user. So there's no central directory or a central server where the whole process goes to. It's just run basically on blockchain. And that is why it is risk-free, because there's no third party involved in your transaction. It's efficient. It doesn't have to go to somewhere where the server might be down or somebody is in charge of that server. It runs just basically on it. I can actually say the question come at the right time, because it is like containerized, actually, because it works on its own platform and our application that doesn't require the third party. So that is how basically it influences cryptocurrency, because cryptocurrency actually runs on blockchain without any central location or server that is attached to that blockchain.
Michael,
I hope that answers your question, sir.
Yes, sir.
Okay, Mr. Mahmoud, there's one more question here. It's from Obeidi. So he's asking, what does a day in working with containers look
like? Let me choose like a very difficult day, because today is a soft day for me. I'm not doing anything today. Today is Friday. So, a difficult day in a containerized world, like let's say in a Kubernetes environment, is let's say I start work and I check the dashboard, Jira dashboard of my team members, and check the update from their ticket to see what it's up, what they close with as in the previous day, the update from what they are doing and what they don't have doing, and of course I check what's on there for bugs, and of course I monitor the system. I check the monitors to see if there's any pattern that is foreign, and of course there is. Let me see. I'm trying to paint the wrongest day right now, and of course I'm checking the monitor and I'm seeing that a lot of Kubernetes pods are restarting, and some of them are entry crash loops, and of course I have to query the logs. I have to alert the team. Okay, this is what's happening, and of course we have to come together. If there's anybody online, come together to call it incidents, to more like do a pair querying and a troubleshooting of what's happening. And of course, if there's a solution, let's say this solution requires that the app engine is failing. Sorry, the API gateway is failing, and a whole region in AWS is failing because our Kubernetes cluster is hosted in two different regions, and so one whole region is failing. So we have to think of, okay, how do we reroute the traffic? So we are thinking of how to reroute the traffic. We're thinking of how to trigger some pipelines. We're thinking of how to rewrite the M chart, edit the M chart to point to a particular load balancer in a certain region. So at the end of the day, we're trying to solve one issue, and there's a user somewhere complaining that our system is slow or our system is down. They won't have any idea what's happening to AWS. And basically, we just sit down all day trying to solve those particular issues. And of course, a lot of Googling. We have to go through Stack Overflow. We have to go through GitHub issues to look for some particular bugs that are happening to you and standups. Basically, that's like the worst day of the DevOps engineer. The containerized world. Did I answer your question?
Does that answer your question?
Yeah.
Okay. So another question from Obede as well. He's asking, what would you do if you want to? Sorry.
Create a Docker file from an
If
app.
you want, yes, like you want to create a Docker image from the app.
You want to create a Docker image from the app.
Like you want to create a Docker file. For example, you have a website and then you want to be able to push them to different cloud provider. Like you want to be able to host in a Docker in AWS or Google Cloud or Azure.
You have to package the application as a Docker image. Or let me say as a container.
That is the question.
Image.
That is the question.
So you want your app to be able to package the application as a Docker image.
Yeah.
You write the app to do it. Application, right? Application is code doing what we want it to do.
Yes.
Right? So if the logic is, okay, I want you to package this application, whatever application I give to you, whatever code I give to you, I want you to package it and do it whatever way you want to do it like that. That is, I think we have tools like Docker Compose, we have Kubernetes operator, and other tools like that. They were written to do things like that. But you just give it a file and then it builds it into a Docker image, then pushes it. So if you want to have to do that, you have to program your app to do it.
All right. Thank you.
Yeah.
Okay, one more question here from Adida Bamidele. So he's saying, I'm currently a software developer and I want to move into DevOps. I know Python programming language. I have learned Docker and Kubernetes. With Git action for CI/CD, what else do I need to know?
Move. You currently work as a software developer and have the basic knowledge of software, how software works. And you've learned all the tools that has to do with Docker and Kubernetes. Of course, you should also have knowledge of how a particular cloud platform, either AWS, GCP, or Azure works. And once you're good with that, you can move anytime. You learn on the job.
All right, does that answer your question, Mr. Bamidele?
Yes, thank you.
All right, thank you. So any other questions for Mr. Momodu? Does anyone have any other questions for him? Okay, I have a question. Myself, I'm not a software developer, all right? So how do you explain containerization to someone like me? Like someone who has no idea what it is, like how do you explain it in layman's terms? How do you explain it?
Okay, I would say containerization is that's still like layman. Okay, containerization is shipping. Let me say, you know how shipping works, right? In the sea, how you say you want to ship a car, right? You want to ship a car from Canada to Nigeria. Now imagine if there was a ship for each container you're bringing in. Like if you're bringing one car, there's a ship for just that container that is bringing the car from Canada to Nigeria. And then at the end of the day, if you're bringing 10 cars, you have 10 ships that's bringing your cars. Because you're using the ship in this example is the server, right? So you're shipping everything with just one server, your application with just one server. And now, instead of using one ship, you discover that this thing is wasting my money. I need to be able to put like 10 different cars in one ship or 100 cars in one ship, right? So instead of having to use one ship to ship one ship or server to ship one car, you now put your car in different containers. Then you put it on the ship.
On one single ship?
Yes, on one single ship. So at the end of the day, instead of just one MB application sitting on a server that is 2 gigabytes in size, you have 1 MB container that is 200 in size, like 200 1 MB containers in one particular ship. So at the end of the day, you have 10 cars coming in one ship, and you're saving money. That's basically what containers is all about. The layman. I hope you get that.
All right. Yeah. I get the gist. I get the idea. Thank you. Yeah. Thank you for that.
I've never had to explain that before.
There's a first time for everything.
Yeah.
So does any other person have a question? Any other question from any other person before we move on? Okay. Since no one has any other question for Mr. Mamodu, I guess we'd have to move to the second speaker for today's event. And he's a DevOps engineer at Bencom Dev Center, and his name is Mr. Peters Kings Monday. Mr. Peters, you have the podium now. You can go ahead and share with us what you have.
Good afternoon, everybody.
Good afternoon.
To the first speaker, please, am I audible enough?
Yeah, loud and clear.
Oh, okay. Thank you. The first
anyway, I hope it's the same for every other person. It's loud and clear on my own end.
Yeah, sure.
Loud.
Carry on, Mr. Peters.
All right. To the first speaker, Mr. Mohammed, you have done a lot. Mohammed, you've done a lot of justice already to what I call containerization. And seriously, I believe a lot has been said. And I just needed to maybe chip in the little things that I think will be relevant. I'm sharing my screen. And I also, from what you've said, I believe everybody has picked something tangible, and we are ready to work with it and see where it takes us next. I won't say much, though I already had some slides that just explain some of these things. And I just hope that as we go along, the whole process will be able to come up with something. Okay, when you talk about cloud compute and containerization, I think one of the things is, first, before I go there, I said, build your career in cloud computing, which is very important. And that is what we do at Beacom for the external listeners. At Beacom, you are definitely going to have this kind of knowledge when you come to Beacom, the master concept of computation. You're going to learn containerization. You're going to learn how to storage data and many more when you get across with us. I think you should browse Beacom, browse through Beacom website, and you'll get a lot. You can also tell somebody who is interested in career building, who is interested in IT world, especially infrastructure, either Python, anything IT. I think you can give Beacom a try. That is why I put this slide. Then before then, if you go straight, I mentioned this, containers in the cloud. That's containers in cloud computing. What is container? You can see the diagram there. Let me be very fast. I say one of the advantages of containers in the cloud is that it's efficient, it's portable, the agility is there, it's easy of management. That's one of the things. The management is so easy. They will have what? Fault isolation. It makes it less faulty or zero faulty. Speed and transparency. These are the things you're going to gain when it comes to what? Containerization in this. So I just briefly explaining, like Mr. Michael asked, if you ask someone or somebody who don't have an idea of what containerization is all about, they might not actually be able to give you something. But then I just wrote something very brief. I said, what? A container in the cloud computing is what? An approach to operating system virtually. By this, the user can work with a program and then without any other this thing. It's not depending on anything, using resources provided. And that is what I have explained here. Container in cloud computing is used to build blocks, which help in producing operational efficiency, vision control, developer productivity, and environmental consistency. Because of this, the user is assured of reliability, consistency, and quickness, readiness of the distributed platform. I just try to give this little explanation. Then I explain again, what is a container compared to what? A virtual machine. Most of us always say, okay, because when you talked about container in the cloud, everybody is looking at the process of what? Virtual machine. And I say what? Sometimes a container is confused with what? A virtual machine, because they work in a similar way, isolating applications without the need of what? Physical hardware. So you can see, if you go through the note, containers are isolated from an operating system, and the manipulation with them is easier. We can understand them as a light form of a virtual machine. So that's a virtual box there at my left. And then that's an application containerization. That's the software that is already what? Put together in a container form. You can see different apps around one that data box there. That is what it means. That's what is just explained. And I say what? A container as a virtual machine, it has what? Has isolation. That is a space reserved for data processing. Authorization as root can mount files and many other things on this same container. Then I try to draw something. What is a container compared to virtual machine? I'm still talking about virtual machine now. So when you have a virtual machine, you will need your infrastructure, you will need your host OS, you will need a hypervisor, another virtual machine around that will help you. And the problem with a virtual machine is it can actually work like a container. But the problem here is, first, the more you put, like the first application from the other side now, when you put on the virtual machine, when you put an application, it takes a lot of space. We can see how big the space it will take. Application one, maybe your binaries, your libraries, then you come in as a guest OS. Before you know it, it's being filled up. It takes a space, a level of space from your system. Then when you come to, because you're using what? A hypervisor, but when you come to containerization, you don't need that. It's almost the same, but it will not take a lot of your data, because it's not looking for the host OS. It's not taking you as a guest library. It doesn't need your hypervisor. So quickly, it gives you an operating system of its own. Then it creates a because there's a Docker, which is the engine of the container. Then it goes into the Docker and makes it a bit easier for you. You can see what the containerization will give you when you're using what? A Docker. And then you can see what it will give you when you're using a hypervisor, which is a virtual machine. So I try to explain them. The benefits of this: containerization has optimized the virtualization in comparison with virtual machine by reducing the number of resources, as I explained from there, and execution time quickly. So it helps you reduce your resources, the number of execution time. Also, companies save money because they don't need several versions of operating system with their respective licenses, just as it occurs with virtual machines. On the other hand, containers allow multiple applications to run on a single machine. Why? Because the kernel of the operating system is shared. This approach is more attractive from the business point of view because of the ease to create applications, assemble them, and move them. Some other benefits of containerization are, there are more benefits that you can see. But then I try to show something here. Look at it here. This is a container. Then first, from the other side, you will see what? Portability, by attracting applications away from the host operating system. This is what it does. There's a container dragging everything. Now, on the other one, you have what? Scalability, easier to scale, fast deployment, high productivity, enhanced security, continuity, and what? I even said enhanced security again. In this aspect, you have two enhanced security. First, the application isolation method of container ensure every application running independently in separate container have their own level of security. It's different from what container orchestration to perform application management, automating installations and management of workload on its own. So these are things you're going to get from there. Then advantage of containers, they are their consistency in cloud storage, application version control, efficiency in their operational activities, productivity of the developers. When you go through it, or if you want this the slide, I can make it available after the section if you still want to go through it and see some of this things that I am saying. I'm rushing them because of time, and then I just want to highlight some of the key points. So how containerization works? I think a question was asked earlier from my previous speaker. The main piece in a container architecture is something called Docker. A Docker is an open source based on the Linux kernel that is responsible for creating a container in an operating system, as we have seen in the diagram above. It is possible to what? Virtualize, manage servers with what? With this. So by accessing a single OS kernel, Docker can manage multiple distributed applications which run in their own container. In other words, containerization is based on software package that is implemented in a single virtual shipment. You can see that single container, that big one, there are so many things that he's carrying, he's dragging them along because it can contain everything. The container are created from Docker image, although the image are read only from the Docker. Don't forget there's a file, there's Docker file, Docker image, and then Docker container. So we'll look at that as we move further in the course of the meeting. Docker starts a network interface that communicates the container with the local host, then add an IP address to create a container and execute the indicated process to execute the application assigned to it. You still understand as we move further. How containerization works, we still continue, you can see it. I still explain it, but the main point here is that Docker engine is one of the key things in containerization. We now said the Docker engine is a software layer in which a Docker is executed. In summary, it is a lightweight execution engine that manages containers. It runs on Linux system and consists of a daemon Docker running on those host computers, a Docker client that interacts with daemon Docker to execute command, and a REST API to communicate remotely with the daemon Docker. You will still get a bit of it as we go further. How do you get Docker? You get Docker container on Linux, Windows, Data Center, Cloud, Serverless, etc. I explain. Then basic classification in Docker. You can see something here. From the other side, you will see hosted Docker registry. You will see Docker trusted registry on premises, Docker hub registry. You see those one from the Docker hub. Now you see Docker trusted registry on cloud. This other one is on premises. This one is on the cloud. Then Azure also use the same registry, AWS container registry. You can see now they have Google container registry. You have all of them there. But then look at it down. That other one becomes what? A public cloud, specific vendors. Then while on premises it becomes what? A private one. You will see how it moves from the registry. You can see many images, many containers inside the registry. That's where it stores them. Then how did it come? It come from a container. You can see the single container here. It has about 3 outside, then many inside the registry. So it goes there, it picks, and then it works with them. I just gave a little classification of how it runs. The need for Docker in DevOps environment. You can see how Docker, look at Docker in the center. The Ansible, the Puppet, everything that you want to use, the chef is already around it, all of them embedded into that what? Docker. Before Docker developer had a hard time assessing, understanding, and implementing development environment. But post introduction of Docker, developer got a relief from setting up the specific development environment. Every time, or rather, they can now focus on building quality code, which has led to improvement in their efficiency and productivity, as I earlier said. Need for what? Docker in this, I also explain it. You can see, you see, talk about what? The lack of Ansible, Puppet, and Chief. For everything, you will need it to provision what? When you do that, use Docker to automate the provisioning of the environment and also deployment of this environment. It does it on its own for you. Docker, the DevOps enabler, it also do this for you. Considering the friction which companies are facing today, a step-by-step approach is required, which cover automation, containerization, and then moving to cloud. In order to achieve a successful DevOps implementation, in case you have an already existing cloud, Docker eliminates the gap between the server and the developer to smoothen development. But if there is no cloud, then Docker provides enterprise solution to build your own private cloud. You can see why you can do that with Docker. Then Docker, the DevOps enabler, look at it here. So many things, AWS, everybody, you can see how it operates. Is given here. You can actually create your own cloud if you don't have one. If you have one, use your Docker to what? Deploy some of those applications. So, sorry. So now after Docker, we now talked about what? Kubernetes. You say what? Kubernetes vocab, they have their own vocabulary. For instance, the node. When you're using Kubernetes as one of the container, because it's either you can also use Kubernetes to do it. Now we say what? The node is basically what? The instances you are creating. Then the kubelet is the application you use in running those instances, which communicate with the master node. Then the node runs on pod. I'm just giving you a breakdown of how this one is done. Kubernetes is done on what? On container. One or more containers are run on this pod. You can see there's a one plus containers are run on those pod. What is a Kubernetes? An open source system for automating deployment, scaling, and management of containerized applications. So when you're doing that on its own, we even say service, one of the services is handle requests inside the cluster or outside, which is public request. Now, usually what it does is it does a kind of a load balancing job. Know where to send requests to, know where to take traffic from and send to. Then we say deployment. Design the desired state. Kubernetes handles the rest. For example, just write your code and drop. Specify where you want it to go. He does the rest for you. And I say what? This is how it looks like. This is the master replica, master node now. From here, you have your control, and then you have your replica. So you have node, then you have another one. So let's say you're using version 1. You can see now there are 4 nodes inside the master replica. We have 4 nodes, the first 4. Now the first one had multiple, the first pod inside the first node had about 4 container, and in the first one with another container. Then the second node had 2 container and another 4 container in it. The third one had 2 container, another one. Then the last node had just a single container. But all these container can be inside the master node. Now, inside the master node, one good thing is it can do you version. It can actually, when you're using version 1, for example, it can quickly automatically spin up version 2 and start working with version 2 and then stop version 1. With this process, you don't have a downtime, because once you set your version 1 and 2, as 1 is running or 3, as the case may be, as 1 is running, it's checking if there's a signal, quickly it moves to version 2 or the next version, and then pick up that one, pick up the second version, that one begins to run before the other one, then terminate the previous one. If you notice any issue or error on the previous version, probably there's a problem in version 1. So that there will not be a downtime in version 1, it pings up version 2 on its own. Then start working with version 2 and then terminate version 1. So with this process, there will not be a downtime. It doesn't give you, you don't have downtime. So you can relax now as an engineer or as a DevOps or as a programmer or a developer to just position this and on its own, it keeps going. For example, I give an example here of what it does. Now look at a YAML program. It was written in YAML. Now, when you wrote this program, what it can do for you is good because it does not require brackets. That's writing a code in YAML, for example. Then basically just in the indentation, you can just do what? Indent by indent, then you write your code. It's more like English kind. So it gives you an option to do. Then you say what? Just basically indentation. Deployment can be done. Pod, services, replication control, and everything can be done. The Kubernetes will create everything on its own for you. And I say this again, that is, it can run 2 versions. If one version is running, so that there will be what? No downtime. If one version is running and there's an issue, it suspend that one, and then I just try to explain what I said earlier. But then here is the code. All you just need to do is specify where this code is going to. Kubernetes will do the rest for you. He will position, he will do whatever you want. You want it to deploy, he will do the whole deployment for you. So that is the idea of containerization, because this process can be automated and then can be done through these applications, the Kubernetes or the Docker. Now I'm not saying that, okay, look at this. First, how do you use? You have to download the Minikube, which can run on OS, Windows, or Linux. That's the application. Then you now have what the kube CTL, kube command line. This is a command where you deploy, when you download the app, as you're working on it, then you use the command to specify and write your code as you want it to be. So, and I say, why Kubernetes? And I say, well, self-handling. That's all I was trying to say previous to this slide. What I was saying earlier was, it gives you what? Self-handling or healing. Then automated rollback. Just like I said, if there's an issue from the previous version you're running on, it will spin up another one and roll back the other one and correct it, and then suspend the other one and then start using the second one. Auto scaling. It does auto scaling on its own. Then load balancing, of course, it will help you out with this process. Then I was not talking about the hypervisor, previous one, because I talked about how hypervisor, how it's similar to all this containerization. So I now talked about it. Why is it not being invoked? What was the advantage of containerization over container over this? I tried to explain what hypervisor is, then a brief history. I gave a history of it, and then this is the environment. This is how it works. There's a hardware, there's a hypervisor before it now go through the OS. That makes you a guest user because you have to run through the OS. You can see how the environment looks like. Then there are 2 types. I also talked about it. You have this type, the hypervisor, and then you have the other one that have OS on it. And then split hypervisor into 2. You can see how it is also rated, the native and then the hosted. You can see how they look like. Then I talked about the types. The first one, directly on the host machine hardware, eliminate the need for an underlying operating system. They are usually used in data centers.
Hello, Peters.
Hello?
Yes, you have 5 minutes left.
Yeah, I'll be rounding up soon. I'm almost done. Thank you. So we have the first one, and then we have the second one. I also explain how they work because of time. Then benefit of hypervisor, so that I will not rule it. I am giving this because some organization might not be able to afford a container at the moment to pay for the services of using a container, but you can actually go through this. It's still not bad. It's just that the other one gives you a better and a faster process, but you even pay more on it. So for smaller organization, before you get to the other side of using a container, you can consider hypervisor. And that was why I give the benefits, and then the types. I actually give the type of hypervisors. And then in conclusion, I said, containerization is a lightweight form of virtualization. that create multiple containers within a single operating system to provide applications in their own namespace. This means that it appears to each containerized application that they are in their own operating system. I've said this earlier. It can also be seen as packaging of software code with just the operating system, library, and dependencies required to run the code to create a single Lightweight executable called a container that runs constantly on any infrastructure. That's another thing. It's a single code. It doesn't matter how you write it or how it was written. Either it was written in Mac, Node, Node.js, Python, YAML, whatever it is, it can do this. When a developer transfer code from a desktop computer to a virtual machine or from a Linux to a Windows operating system, containerization eliminates this problem by building the application code together with the related configuration file, libraries, and dependencies required to run it, thus making it portable, scalable, fast deployment, high productivity, enhanced security, easy management. I know there are so many questions, and I just want to say thank you for listening. Please let your question come and let's see how we can treat them together. Thank you for listening.
All right, thank you, Peters, for that presentation. If you have questions, this is the time to ask questions, please. Does anyone have questions for Mr. Peters? Okay, let me ask a question. How do you convince someone who wants to get into tech that they should go into cloud computing? Like,
okay.
Or the career tech, like career path in tech. So how do you convince that person to choose cloud computing or DevOps?
It's easy. First, IT, the whole world is going digital. And whatever it is, you will need someone at the other end to maintain that process, that available process. If everybody is producing cars, there must be an organization that will be responsible in fixing these cars. You don't just want to buy a car and then you don't know who will fix it. We won't be able to believe it that, okay, having a car at the same time, you don't have mechanics. So you just need to keep buying a car. When your car develops faults, you dump it and then get another car. I don't think the resources will be available. So you will definitely need, even the producers of those cars will need people to come and learn maintenance. You can't have a house and you don't think about how to maintain your house. You don't have anything in this world and you don't want to maintain. So what I'm saying is, basically, when you look at all this process, you now look at yourself. Where do you belong in this developing world? First, you might not be the one developing these applications or these programs, but then you can come in by contributing your own quota, making sure you get to the end of it so that you'll be able to get something, to fix something. So you tell yourself, do you just want to be a novice of the whole technology? You are not a producer. And then at the same time, you cannot, how do I explain it now? You are not the producer, and at the same time, you cannot you are not the producer, and at the same time, you can't fix. You just, every time your system or anything around you goes down, you have to go down, look for someone who can fix it. Then what's your duty? So basically, you're going global. I can only tell you that, look, do something that nobody has known before or done before. learn something that nobody think is possible. Then when you're able to do that, you have an edge over your mate, because what you're able to learn, people, when your service is needed, definitely DevOps service will be needed around the world, as the people are developing different strategies and different softwares and different applications. Somebody needs to be at the back end. And if everybody is not thinking about it, and if everybody is not going to it, definitely the person that goes into it, or those that are aware and do it, they'll be the only hot cake in town. I bet you, whether we like it or not, DevOps job is maybe the third, by research that I did December last year, the third most sought after right now, because everybody wants to be safe security-wise. Everybody wants to have applications and programs that are secured. And so if you don't have anybody around it, so I would just ask you, if you won't want to even be into tech, won't you want to know the secret behind all these things? Won't you want to be the one creating something that someone is going to use? And so you can start from there. And that's why DevOps, I'll just tell you, I'll just tell you, DevOps is something to think about. DevOps is something to imagine. And if you can imagine it, if you see a light in it, you want to do it. That's basically, I won't tell anybody is the best, but one thing I know is it's something you can give a try in your IT world. It's something that everyone needs to know, or everybody needs to have an idea. Basically, that is it. I hope that answers the question.
Yes, it does. Thank you for that. We have one question here from Damola Bamidele. So he's asking, does K8 automatically generate, does K8 automatically generate containers to avoid downtime, or you manually program it yourself that your program should run on 2 or more containers?
I think does A8 automatically generate containers to avoid?
All right, let me answer that, Peter.
Hello?
Yeah. Let me answer that. You specify the auto healing parameters. For your auto scaling group, for normal server EC2s or virtual machines, you define the parameters for auto scaling and auto healing. Then for load balancing too, same thing with K8. K8 orchestrates containers. It tells it how it's your function, number of nodes. You are the one that will specify the number of nodes that should be in your pod. So when a node dies, the K8 automatically generates the node. For example, your pod, you want to have 3 nodes. So whenever anything happens to your container, the K8 Kubernetes will spin up another container to complete the number of pods that is supposed to be there.
Okay. Thanks. I get your point.
Okay, I wanted to add, but it's fine. It's fine. Since you understand it, it's fine.
All right. Does any other person have a question for Mr. Peters? Any other question for Mr. Peters? Okay, I have a question. This containerization that we're talking about, is it like the framework or the platform? Like exactly, because I know in some programming languages you have frameworks. Just like in PHP, you have the E framework and the Laravel framework. So is containerization something like that as well, or is it something totally different from what I'm saying?
Basically, to me, in AWS is a service, it's a platform because it's a service.
That's containerization itself.
Yeah.
Is a platform.
Yeah. It's a service because you basically just specify, you go to, like if you go to AWS, among the services that are available, there's a place you can, I think so, yeah. It is.
All right, thank you. So any more questions from anyone? Does anyone have any other question before we move on? Okay, since there are no questions again coming from any angle, permit me to make a presentation.
I have a question I want to ask the class house. Maybe they probably understand. That means I want to know if they actually understand the whole thing. And the question I want to ask is, it will go to, I might mention names if you give me the opportunity to. Mr. Bayo, can you hear me? No, sorry, let me ask Mr. Ghosttime. Let him do justice to this. Differentiate between Docker file, Docker image, and a Docker container.
Sorry, Mr. Peters, as much as we'd like to do that, but we're running on a very tight schedule. So we'll just move on with the next event.
Okay.
I'm sorry about that. That would be nice to do, but we're running on a tight schedule.
Thank you.
So I'll be sharing my screen now to make a presentation. Okay, can you all see my screen?
Yeah, it's coming up.
All right. Okay, like I said at the beginning of this event.
It's still loading, please. So it's not coming up yet.
Loading.
Yeah.
Oh wow, but it's clear on my own side. So tell me when you can see it. Can you see it now?
Fine.
All right. So this cloud hosting event was hosted by Bencom Dev Center, and Bencom Dev Center is a multi-location technology, talent development, and solutions platform. We're located in various locations. First of all, virtually near you. We have locations at Lagos State, Oyo, Kano, Kaduna, Ogun State, Delta State, and we have plans to expand to many more locations. All right, so to find out the full list of, or to see the full list of our locations, you can visit bencom.net/campuses. So what do? We offer a couple of services, and on that list we have the Bencom Academy, we have the Bencom Tech Internship, we have the Bencom Tech Apprenticeship, we have the Bencom Community Events and Projects, we have Lightspace, we have the Bencom Global Tech Program, the Emigrate Program, Bencom Mentoring Platform, Labs by Bencom. So let's drill down to some of these services. The first one there is the Bencom Academy, which is facilitated by Bencom Dev Center. Each is an intensive training program, and each technology or application development class is typically 4 weeks of intensive training. During this period, we shall take the participants through our training curriculum for that knowledge track in a Montessori approach. We have a number of classes available. We have the Python, mobile app, PHP, MySQL, Foundation, and lots more. So you can find the full list of available classes at bencom.net/academy. So the next service we have there is the Lightspace. So this provides helpful workspace intended to encourage collaboration and drive innovations in the startup ecosystem. We have spaces that are created and designed for various events like seminars, conferences, and get-together. So we have this Lightspace in our various locations across the country, and to find out full the complete list of locations, visit blog.bincom.net/campuses. So moving forward, we have the Bincom community events and projects, which are geared at giving back to the community and building the tech ecosystem. So they focus on informing and exposing the youth to the current technology trends and how to prepare for the future in tech. So these community events are divided into 5 categories. We have the masterclass, we have the meetups, idea sharing, explore on the move, challenge, and brainstorm. Some of our other initiatives include the Bincom Tech Network. Like I mentioned earlier, we have the Bincom Academy, where participants are trained in a particular knowledge area. So that Bincom Academy uses Bincom Tech Network, Slack for collaboration purposes. Interaction between facilitators and participants take place in a dedicated channel in that Bincom Tech Network. So the next one is the Bincom Tech Club, which creates an ecosystem that enables tech enthusiasts who have little or no knowledge of tech to learn and rub minds with tech experts, leveraging on the tech community to front-end the possibilities for individual or club members to become tech experts themselves. So in our community events, like I mentioned earlier, they're divided into different categories. For the meetups, we have various meetups. We have the PHP meetup, we have the cloud hosting meetup, which is the one we're currently having now. We have the Angular meetup and lots others. And then we have the masterclass and the idea sharing series. And another idea sharing series, we have our Bincom ICT Career Talk, which takes place every last Saturday of every month. And we have the Emigrate Open Day as well. So next one we have there is the Bincom Global Tech Program, which is a solution to launch your tech career globally. So if you have a tech career or you're looking to get into tech, this is the program for you to launch your tech career, not just launching it on a local level. This program helps you launch a tech career globally, and it is focused on 3 key pillars. First is to learn skills, then you gain experience, and then exposure. So we have a program that allows you to learn tech now and pay later. So if your worry is that you might not have the money to start learning tech, this program has that covered. You can actually learn and pay later. A video that explains the Learn Tech Now, Pay Later program that I just talked about. Apologies for that. So let's continue. Can you all hear the video?
No, the voice is fainting.
The voice is faint?
Yes.
Any your income after this program.
It's okay now.
Means that all you need is your laptop device, a hunger and a passion for IT. Those are the core tools that you need. The total cost of the Bincom Global Tech Program for the period of 1 to 2 years is just 1.2 million naira. But you don't need to worry about that because it gets better. We have various financing options to help you cover the cost of the program. So you don't need to have any money to even apply or be admitted to the program. One of the financing options that are available for this program is the income sharing agreement. What that simply means is that the company will sponsor your learning. So you will learn for the period of 1 to 2 years and you only start paying back when you get a job and you start earning your income after this program. This means that aside from skills, experience, and exposure, the company is also willing to invest its own money on you. That's it. What are you waiting for? You need to go on our website, beacon.net/global tech. You need to register and then launch your global tech career. I'm sure that the tech world, the tech industry is waiting for a great talent like you. Thank you.
All right, moving on. The next we have there is the emigrate, which is pronounced emigrate. So it provides tech-enabled visa opportunities for people in tech, either the technical side or business side of tech. So it gives opportunities to live and work in countries like the UK, USA, Canada, and France. So the emigrate service is divided into, sorry about that. We have the free services and we have the premium. So if you're interested in this service, the first step you need to take is indicate interest at bincom.net/emigrate. And the next step is you request your emigrate service at blog.bincom.net/emigrate pricing. So we have the emigrate open there as well, which holds typically 2 Wednesdays in a month. So if you're interested in attending either or any of these open days, all you need to do is visit bincom.net/emigrate open day to book a spot. So we have Labs by Bincom, which is a program that helps people that have acquired a skill or two in tech and you want to join a team of like minds and build a startup from scratch. So if you want to be part of the next cohort of Labs by Bincom, all you need to do is visit bincom.net/labs to join the next cohort. So we have the ambassador program. The Bincom Dev Center Ambassador campaign is a partnership with My Circle, bringing the ability for people to earn from the network and positive social influence. You earn 10% from Bincom Dev Center for any of its services which we refer. For example, you earn 10% of the payments made by a prospective Bincom Global Tech Program participant, referred by you, which is 120,000 naira. So you can send us a mail, bincomdevcenter@bincom.net. You can dial the number that is displayed on the screen, or you can visit our website, www.bincomdevcenter.com, if you want to reach us, if you want to contact us. So thank you for listening. Thank you for being part of this event today. If you have any questions or feedback based on the presentation that I just made, you can ask a question now, please. Okay, I'll take the long silence as no questions, no feedback. All right, in that case, I would like to appreciate everyone for being here. This has been a wonderful session, and I appreciate everyone for making out the time, speakers especially for sharing the information which they did with us today, explaining to us cloud, compute, and containerization. We appreciate the time, we appreciate the knowledge, the information which you shared with us today. And at this point, I would like to bring this session to an end, and I bid you all farewell and enjoy the rest of your day and have a lovely weekend. Thanks.
Thank you.
Thank you.